Seems to be working. Hello, good afternoon. I'm Jan, and this talk is about the road to OpenStack at the University of Edinburgh. University of Edinburgh, a little bit short background about the university. One of the leading universities in the world. Well, that's trying to be. At least we are at the top 6 in the UK, and some were ranked 6 or 7 in Europe, depending on whom you ask. Founded a little while ago, definitely older than I am, 1582. We're also quite a large university population. That's now from Wikipedia. I'm not quite sure, 100% convinced, but 45,000. I know that we are staff 8,000, more than 20,000 students. So I'm Jan Winter. I work for Research Services. We are a subdivision of IT infrastructure division. So we are a central division in the University of Edinburgh. So we don't bound to any specific college. We providing IT service for researchers for all different schools, colleges, researchers, communities. We're quite small team. We are 10, some support folk, some people who interact with researchers, and at the moment we are 2.5 men and systems who run the services. Strategy and objective for our cloud installation. Some buzzwords: move higher cost service delivery channels to lower cost delivery channels. But definitely what we tried to achieve to build is a cloud service what's highly automated and self-service. Few examples. We got a registration service for our cloud. It's a web application where you can register to get a project on OpenStack, where you can define who's the member of your project, setting quotas. So in theory, you don't need to speak with us. You just need to go to this web page and register yourself a project in OpenStack. Cloud objectives. Yeah, pretty forward. Provide flexible infrastructure for compute, storage, network services for research. A little bit background from us. So we are coming from an HPC sector. So most of our customers are HPC users. Where's OpenStack in this picture? Provide user with flexible self-service provision of computing infrastructure. So basically, again, yeah, what we are trying to do is offering compute, storage, networking, and what they need to do, build application on top of it. What kind of user do we have? As I mentioned before, so we are working in the central service for the University of Edinburgh. So we got a wide range of different users with different needs from the cloud. One of the biggest things what is currently what keep our cloud busy is we are a tier 2 partner from CERN. So CERN workload, especially from the Atlas project, is running on our cloud. So how that works is quite easy. CERN got a cloud scheduler, so they're speaking directly to our OpenStack API, and then they are firing up jobs and keeping our cloud busy. So the utilization is always up, so I can sell it very good to my boss. It's very nice from them. We also have Sahara. So people who are keen can do big data science workload like Hadoop Spark on our cloud. We have a couple of other things. We got many small researchers who basically treat our cloud as just VirtualBox. So we're logging in, we're struggling with network, we don't understand that, and firing up one VM to run a specific application on Windows or on Linux. More importantly, need to meet organization mission. Don't throw money at the challenge. Money does not grow on trees. Yes, so we tried to build this cloud very cheap. As I said, we're coming from an HPC background. Basically, what we have done is we're running our OpenStack on CentOS. OpenStack installation is, or we use the CentOS packages. Hardware is coming from our cluster, so it's cheap. And that's the crew change.
Hi, I am Kenneth Tan from Sardina. So we are the partner, not in crime, hopefully. So we are a OpenStack automation platform vendor, European player. Historically, we primarily did business in the large-scale sites, some very large-scale sites, in government, meteor, finance, defense. And today, the team is pretty much distributed across Europe. So in terms of the route to solution, the journey that we took was first look at the problem definition and solution design, and work out what's the system architecture, go through the hardware specs, and very importantly, project management side of things. What's happening, when, by who, that's got to be very clear. And the what's happening when, by who, we have during the implementation period, we had a daily update call. Even if it's a 3-minute hide, there's nothing happening, by. And so you have to plan for, and when it comes to you formulating the plan, you've got to plan for production from day 0, build for production from day 0. And since this thing isn't a toy, HA isn't optional. It's not a luxury. And then as you want to scale up the system, it's got to be monkey capable. And from a vendor standpoint, it's very critical. Do not treat your client as a guinea pig. And you've got to consider the full life cycle, deploy, operate, and then into upgrade.
The solution design. A little bit about how our cloud looks like. I've changed that number, I think, 2 times from 16 to 17. I should know it. Should be 16 or 17. It's a quite simple setup, or a very typical OpenStack setup. There's absolutely nothing fancy in it. So we got 16 nodes where we have a Galera cluster on it. We got 3 nodes MongoDB in it, where we store metrics from Zero-meter. We got 3 nodes for RabbitMQ, our message queue cluster. Then We have our servers, what we have in OpenStack, Nova, Neutron, Heat, Sahara, Glance, Cinder, I think that's all, spread across the nodes and basically put an HA proxy in front of it. So all the communication runs through an HA proxy, and everything is basically twice there. So we got 2 times Nova. So when one Nova server goes down, we still have another one. Storage, we're using Ceph for everything. Block storage, object storage. We got 9 machines from it. These 9 machines are fully stack packed with 8 terabytes. So we found a chassis where we can put 16 hard drives in it plus SSDs. So we're storing the journals on SSDs. Data goes to the 8 terabyte hard drives. We're running a replication of 3. That gives us a raw capacity from very close to 1 petabyte. Compute, so hypervisors, 200 plus nodes. That means the management performance should be able to handle the load from round about 200 hypervisors. Currently, we have roughly 50 in it. Network, everything is 10 gigabit. The hypervisors are connected with 10 gigabits. Only the Ceph storage server, they got 2 times 10 gigabit. So they got their own network for all the internal Ceph communication between the Ceph storage server. And then the second network card is the Ceph connection to the Ceph clients. We split everything up in VLANs. We got 2 VLANs for the tenants. So for the VMs, we got 2 network ranges what we're offering our users, one with public IP addresses and one range for just routable in the University of Edinburgh. When we got 1 VLAN for management, 2 for Ceph. Integrated with broader University of Edinburgh IT service. Basically what that means is Keystone is connected to our ID server. We got the central NAS system, very big in the university, and all the VMs should be able and capable to mount space from there if you want to access it.
Quick question. Here?
Yeah.
Why don't you utilize InfiniBand? Because I guess you have that in these nodes.
InfiniBand? Yeah. No, we don't. We don't have InfiniBand.
But it's a retired HPC system?
Yes, we're running an HPC system without InfiniBand. Yeah. We got that on the previous cluster, but this is not a big use. Just to say a little bit broader, so our HPC cluster is basically a cluster for batch systems. If you want really fancy HPC, there is a national-wide supercomputer Archer, that's also set on the same site, and basically there's a user community exchange. Deployment phase. Yes, deployment. The ingredients, what the configuration needed, ingredients ready, make sure hardware are available, server, storage, networking. That was in this case very, very easy because we got an existing HPC cluster and we just disabled some nodes, reconfigure VLANs, and say, oh, that's now OpenStack. Only what we actually bought was the Ceph storage server. Unfortunately, I'm not allowed to take any more HPC nodes because the guy's getting really upset with me. So I need to buy now my own hardware. As I said in the beginning, automation is quite important, so automate, automate, automate. System configuration is equal input for automatization, deployment of entire system, fully automated. Reduced project risk is equivalent to increase operational confidence. How we're doing it is we use Foreman. Foreman do pixie booting of the worker nodes. And we're using SaltStack to configure the nodes. So how does it work is, and that is, it's not 100% is automated completely. So at the moment, we don't have any smart, clever switches, so you need to manually switch the VLANs on the switches. And then we got a process where we said, here's a new node, that should be please a hypervisor. Foreman does the installation. It's registered automatically in SaltStack, and once this machine boots up, SaltStack runs and configures this node. So this is the full OpenStack plus self-deployment. Yeah, basically, then is the showtime. Input configuration, inventory, run the deployment, get some coffee, or how are my colleagues drinking tea. And that's another crew change.
So now how do you then take from concept into reality? So the deployer is pre-tested, proven off-site. So we have a full CI/CD process on our end to allow us to prove the deployer operation before you actually run on a customer site. And we built this assuming that there's zero knowledge of OpenStack necessary. How does that work? Now, if we were to wind the clock back to, I don't know, let's say 1995, you ring up your hardware vendor and you say, Mr. Hardware Vendor, I'd like to buy servers with Linux on it. What would hardware vendor say? In all sorts of different ways, no. Today, you ring up the hardware vendor and you say, Mr. Hardware Vendor, I'd like to have servers with Linux on it. What would hardware vendor say? Which one? When? What's the difference between 1995 and today? The guy at the factory didn't get any smarter. And chances are, the guy in the factory doesn't even know what is Linux. What's the difference? Automation. And automation has to assume that there is no knowledge of OpenStack necessary. Then, again, you go back to detailed planning, work out what's to be done, who's going to do it, and then the entire process planned out went from 0 to operation in approximately 8 weeks. 6 weeks waiting for storage hardware to arrive. So now, I mentioned earlier about the 3 phases: deploy, operate, and upgrade. Now, I want to fast forward to the upgrade phase, and then I'll come back to looking at the operate phase. In the upgrade phase, what does the operator actually want? You want 2 things. What are the 2 things? But before that, as an operator, you have a requirement of keeping the system up and running at all times, And we are also faced with the fact that you need to do sequential updates. So no, you can't sit around and wait for 5 years to do upgrade, because that's a lot more risky operationally. You're doing 10 upgrades in one go. And how do we keep this thing running? You need to make sure that solution architecture was built for upgrade, which basically means whatever that you did 6 months ago, if you screw up there, it's going to bite you 6 months later. And you want that upgrade to happen, satisfying those two requirements, actually doing the upgrade without downtime. And you've got to make it monkey capable. So now if we then turn to look at operate phase, you have a number of challenges around uptime, availability, resource management. How do you operate a system in an infrastructure as code model so that you can change it at any moment in time? So in relation to reliability, uptime, availability, this thing isn't a toy. So HA is not a luxury. And yet, when you look at the point of view of the service consumers, i.e. the users of the system, they're only interested in this thing running. They don't care how you keep it running. That's not their business. At any moment in time, when any service is not available to service the consumer, whatever the cause may be, that, from the service consumer's point of view, would be downtime. So you can then take downtime risks, you split it into two parts, intrinsic risk and extrinsic risk. Here, I would really want to focus on extrinsic risk. Intrinsic risk is another long topic. So extrinsic risk downtime, you can deal with it with a traditional HA solution architecture. Now, let's go one step further. What is OpenStack? In essence, it's just a series of intercommunicating process services. HTTP, MQ, database, anything else? Come on, we have a room full of people. Storage. What else? Anybody? Okay, so in essence, we can then take the services, split into services that are configuration only, and services that have data and configuration. So the ones with data, how do we safeguard against non-availability? In essence, we're looking at replication, replication, replication. So when you're then looking at replication, you've got two options, either the two-node model or the odd-node model. So really, this is a traditional HA model, right? And then when we look at HTTP services, it's a web server. Let's not make it any more complex than that. Treat it as such. So we then apply HA for web servers. MQ? What's MQ? Put stuff in, get stuff out. So what do? Replicate the reader and the writer. So basically, keep an extra copy at all times. The smarts, the solution architecture. Screw it up, it'll come back and bite you. What else do we need? Well, got to sort out usage accounting, billing, logs management, metrics management, monitoring, capacity planning. And problems encountered? Well, downtime due to running out of disk space, affecting Ceilometer MQ, and there are some networking hardware problems that are still being investigated, and there were some Cinder problems encountered during Okata upgrade.
Yes, 2 years later, 2 years in service. Worked well, growing. Because of our provisioning system and configuration system, and what we plan our management nodes ahead of a workload, we can now easily just add hypervisors without any configuration changes, without any extension for the management nodes. It's not true. My MongoDB database is running out of space. But other than that, we can just add more hypervisors without any other problems. We ordered another 2,000 cores, what should coming this month. System can be supported by just one user. Yeah, sure. Key lessons learned. What our key lessons basically is, didn't spin up your own Linux distribution, so don't spin up your own OpenStack either, because we are a very small team. I was very glad to have help from Sardina. Not planning, but rather experience plus planning, and more. Experience plus planning. Make sure your vendor is able to support your operation when needed. Oh, I was expecting another slide, but OK. Key lessons learned. What else can I say about key lessons learned? Yes, so it's all of course, depends on the cloud. I mean, in our use case, it was quite easy because this was a new service for the university. So from day one, I was definitely we don't have a huge amount of workload. It is basically coming constantly, slowly coming new user in. So we need to advertise that in the university. So I could handle the load quite easily. But planning is definitely a thing. For example, we have done, for example, done a mistake with our Ceph server. The documentation is quite clear. Per 1 terabyte of storage, have roughly 1 gigabyte of RAM. And that is absolutely right, because we got, let me count, 120 terabytes roughly in one Ceph server. And we started with 64 gigabyte of RAM. And the outcome was that all our Ceph machine was swapping heavily. So then we bought more RAM and stick that in. Thankfully for Ceph, bringing machines down and add some hardware was quite easy without any complication. Otherwise than that, we don't have any thank you slide. So I say thank you for coming.
Questions?
On your first key lessons, so which OpenStack distribution did you use?
So the starting point packages were CentOS packages with additional RPMs that came from us. So we maintain a model whereby there is CentOS Plus. And there are certain situations when there are errors, there are fixes that we implement that are not in the public versions. And then the Visuals product, we have another set of RPMs that are for example, for metric collection, we have a time series database, log management, et cetera, et cetera. So those are non-standard.
So you use upstream OpenStack, or?
Sorry, what?
So you use OpenStack from the upstream, or from the?
No, we use them from the CentOS repository. That's our source. And it's basically that. One is coming from Sardina, where we have a problem with Cinder after our last update to
Kata.
Thank you. Yeah, but then other than that, just pure CentOS.
So you didn't mention the usage. Do you have a sense of how many VMs?
Usage, yes. So we got 50 hypervisors because they are coming from our HPC cluster with different memory configurations. So we basically have two types of flavor. We got medium flavor and different sizes, but always with a ratio with 1 core and 2 GB RAM. And then we got, we call them L flavor, larger flavors with where the ratio is 1 core 6 GB. And that's we are then handling with host aggregates across the hypervisors. We have roughly 1,000 vCPUs in use. And that is, it's a little bit different at the moment. It depends on how active CERN is. I would say 200 VMs. That's our workload at the moment.
How do you handle the federation with CERN? In other words, how do they know when you have excess capacity and they can launch workloads on your cloud?
I have not so much input into that. That's physics departments who are doing the communication with CERN. But what we are doing with CERN, they just got a project with quota settings. And then they can fill it up. And that's it is.
So it's not that CERN is just monitoring your capacity and then sucking up
No.
excess.
No.
It's just a single project and then
Yeah.
number of
Exactly, yeah. Quite simple.
What kind of HPC optimizations do you apply for OpenStack? Do you use SRIOV for the 10 gig and other things for the pinning?
No, we don't. That's pure chemo standard config. No big changes at the moment.
Do you give your users full access to everything in OpenStack? Like they can upload images, they can use Neutron?
Yes. So a community or a single user, whatever it is, can, as I said in the beginning, they can create their own project. They are just a new normal user, a normal member in this project, and that belongs to him. And he basically can do what's he want with it. This is getting more challenge, especially in theory we need more resources to actually really monitoring what they're doing. So that's why I'm always very keen on teaching our user, don't use external IP address, don't mess up your security groups with allow any, because then you got the thing what we just have 2 weeks ago. Someone spawned half a year or a year ago a Drupal installation up, opened it to the world because he wanted to test it from home, and now this machine was doing bit mining. Thanks.
So do you have workloads on your cloud that are essential to other academic, teams or people? In other words, is there part of it that's like production quality services?
Yes, so we got a Jupyter notebook service for the university running on our cloud, what is a little bit mission critical, yeah.
So how do you handle if students are using too much CPU or stressing your storage?
So storage, we don't have at the moment. We're just monitoring how many IOPS system or how many general IOPS on our Ceph cluster. When something goes completely mad, the only thing would be that we investigate which VM is causing it and getting in touch with the user. But that is all a manual process. Stressing CPU is in theory not a big problem because in theory we not really oversubscribe hypervisors. Because all of my colleagues with a HPC background, they were saying, oh, we are selling here 1 core, so this user get 1 core. There's no oversubscription needed. That's not 100% right, but yeah.
I have an interesting story. I'm from the computer science lab at MIT, and I had a bunch of people also tell me that they couldn't live with oversubscription. And out of hundreds of users, one person noticed and actually asked for the special aggregate I made that didn't oversubscribe. So I set aside a smaller portion that I was doing for the one-to-one mapping that you all wanted.
Yeah.
Divide GPU resource. And the larger section was at 4 to 5 terms. And I found similar things with memory as well. That people pick a big memory number and then never address it. So I was able to do this. Memory oversubscription is scary. I'm not sure I would recommend it.
So
Actually, what I would add to that is that try this, and I bet you every single person in the room will have exactly the same situation, okay? Look at how many cores you have on your laptop and type the following command, ps-aux pipe to wc minus l. Number of processors, definitely much larger than number of cores. So when you start your web browser, do you tell the kernel, I need how many cores and I need how much memory? Do you do that? You don't. So why do we need to tell OpenStack exactly how many cores and exactly how much memory? And why do we need to map that memory to amount available on the host? A question. And if you want to discuss that, let's talk.
Well, one of the great ways to get rid of this one-to-one argument that people will make to you is to keep metrics on your CPU usage in your VMs. You'll find, or at least I've always found, that the CPU usage is 8% per VM, so on and so forth. And so when people say, I need all of this stuff, you can basically go back and say, no, here are the aggregate numbers, and here are your numbers, and I'm sorry, you really don't.
That's absolutely right.
That there are occasional workloads that you actually do need that. That's a great. It's a great solution to carve off a chunk and say, here's fast storage, here's one-to-one CPU, application. But if you keep the metrics, usually you can win that argument without expending any effort. You just say, here it is. Look.
Actually, what you can do is to take it one step further, track the actual utilization.
That's what I'm talking about, taking a time series database and throwing it into pictures.
Right.
Cut, paste, and send in an email. Here you go. Here's your usage. Have a nice day.
But then further, use that metrics to drive automatic rebalancing of the system. Figure out how to optimally pack the VMs, and that way, you're basically shifting processes around, data center wide, not just laptop wide.
So to underline the point that users are way overestimating how much resources they need, we launched a model where we had a billing, a price list. CPUs. We described it as you get a core and you get 6 GB of RAM, actually the same ratio,
Yep.
20 gigabytes of disk. We had all those battles where we said, you don't need to replicate your hardware one-to-one. Why don't you start with this? And then much later we found out that we accidentally were selling them one hyper-threaded core instead of a real core. So we actually doubled our vCPUs for free. No one ever complained.
That's brilliant marketing.
We sold the cores, well, not really.
Yeah, but because we also have this price model, in theory, it's also then a selling argument to improve it, because we can say, okay, look, we got 1,000 cores, 1,000 cores are in use, and cost recovery is working because we are billing the users, so we could buy more hardware.
So not in this particular instance, but in some other commercial sites, you do see the ability to dynamically pack VMs down to much fewer hosts. And then as the workload expand again, bring them back up. And during those periods of time, you can then reallocate these nodes to go do something else, or to serve additional workloads, or to put them to low power states. And as the workloads require, bring them back up. And when you're running some of the very large estates, there's a particular application that I'm very familiar with, where in production run, daily crank, 10,000 physicals. There's 10,000 physical nodes. So if you can shrink that down to a third of that size, that's a load of cash.
That's a comment that we should stop.
Yeah.
So who wants to talk with us? I guess we can do it.
Yeah. So we'll talk about that later. Thank you, everyone.